Welcome to my DSP lecture video series 4. Here I introduce Twiddle Factor and 4 and 8-point Twiddle Factor value. As last lecture video series 3, we discussed with basic formula of DFT and IDFT. Now here we see the modified formula of DFT and IDFT. As you know, we subdivided the DFT and IDFT formula with magnitude and phase. Here I first discuss with phase part, and using some formula we write here modified formula of DFT and IDFT. Just in place of e to the power minus something, we write here capital W of Kn and N for DFT, and for IDFT we write capital W of minus Kn N. So now considering modified formula of DFT is capital Xk equals to summation n is equal to 0 to capital N minus 1 small xn capital W Kn capital N. And also for the modified formula of IDFT as small xn equals to summation k equals to 0 to n minus 1 capital Xk W minus Kn N, and before writing the formula of IDFT we always write down 1 by n also. So capital Wn, now we write e to the power minus j 2 pi by capital N, which called also the Twiddle factor, and also we call this capital Wn periodic phase rotation factor. In the below mention, also take note that e to the power j theta is considered as cos theta plus j sin theta, and similarly e to the power minus j theta equals to cos theta minus j sin theta. Now find capital W4 value. So for n point DFT, here n considered as 4. Now capital W4 is e to the power minus j 2 pi by 4. So that means cos pi by 2 minus j sin pi by 2, which equals to minus j. So here Kn vary from 0 to 3. Then capital W value varies from capital W0 to capital W3. That is W04, W14, W24 and W34. So now phase means here we consider as 360 degree, where n is 4 means each angle considered as 90 degree. So we here consider a circle and divided with 4 separate area, each area consider of 90 degree shift. Previously we mentioned that system calculation made by clockwise manner. If e to the power value is minus sign, so the capital W04 point considered here in x-axis starting point and next point consider capital W14, so on. Also find the value capital W0 to capital W34 using cos theta sin theta formula. So now write the value in circle. The most interesting part that previously I mentioned, this Twiddle factor is periodic phase rotation factor. So now we find the value of capital W44 value and using cos sin theta formula, that point consider same as capital W04, and mathematically we also find similar value with capital W0 value. Now if we consider 8-point value, then angle considered as 45 degree, and to value we find out that is capital W08 to capital W78 here also, like this way. And here same for W44, similar value with W04, for W8 same as W4, W08, W88 and W168 are same position and with same value, that is 1. So if we know the value of W08 to W78 value, then we can also easily find out any value of Twiddle factor value for 8 point. For example, if we consider capital W21, 8 is similar value of W58. For next W23, 8 is similar value with W78, and capital W16, 8 is similar value with W08. Same here for we considering case of 4-point. If we try to find out W19 4 value, so here we consider, and in case of W34 similar value are W19 4, that is J. Thank you. Welcome to my DSP lecture video series 5. Here I introduce with various Twiddle factors properties. Considering two properties are periodicity and symmetrical. For periodicity property, we write down here capital W K plus N, capital N is same as capital W K N. And for symmetrical property, here we write capital W K plus N by 2 N is similar as minus capital W K N. We considering here the periodicity equation is number equation 5 and symmetrical equation is 6. Now for periodicity, if we already considered the formula, if k equals to 0 and in place of n we write down 4, then W4 0 plus 4 equals to W04. So that means W44 equals to W04. So we already know W44 value is 1 and W04 value also are 1. So it's proof that as for the periodicity property, W44 value similar with W04. So as formula W K plus N equals to WKN. As last video in a circle we already discussed in detail. Now as example of symmetry property, as already mentioned the formula, again k equals to 0 and n equals to 4. If we consider W0 plus 4 by 2 4 similar value with minus W04. So we know that W24 is minus 1 and minus of W04 is minus 1. Then W24 value same as minus W04, that is minus 1 are seen in the circle also. Here we consider the point anti-clockwise. Thank you. Welcome to my DSP lecture video series 6. Here I introduce linear transformation matrix in term of DFT. Modified formula of DFT, as we know capital Xk equals to summation n equals to 0 to capital N minus 1 small xn capital W kn. Now elaborately we can write down also capital Xk equals to small x 0 W k into 0 n plus small x1 W k into 1 n plus small x2 capital W k into 2n plus the equation up to consider again plus x n minus 1 wk into n minus 1 n as considered as equation 7. So from the equation 7 n number of complex multiplication and we also see n minus 1 number of complex addition are there. So for n point DFT, if we consider n point DFT, n square complex multiplication, that is Cm, are present, and also n into n number n minus 1 complex addition, that is Ca, are present. Now for the next slide, here for if we consider a 8 point DFT, the complex multiplication is a 8 square, that is 64, and for complex addition 8 into 8 minus 1, that is 56. In real application, if we consider that time n in place of 8 we consider 1024, then the complex multiplication square of 1024, that is 1048576, and for complex addition, that is 1047552. So minimizing the mathematical burden, we can use DFT. We can find out basically DFT IDFT as a linear transformation sequences. As we know, small xn, if we perform the DFT capital Xk, and vice versa for the IDFT. If small xn consider as linear transformation, that time we can write down small x0, small x1, x2 as seen in your slide, and same thing for the capital Xn, whether capital X0, capital X1, capital X2 up to capital X n minus 1. Now this part, previous slide, you see the magnitude part we consider and how to considering the magnitude part. Now we consider the phase part, which also called linear transformation matrix, or maybe we can say also DFT matrix, n by n DFT matrix we can also say. Here the matrix formation in like this manner. This is the generalized formula, whether we are considering 1 1 1 up to 1 in the first part, that considering 1 wn w2n up to wn minus 1 wn, then w2n is considering to wn minus 1 to n, and similarly w2n next considering line is w4n w2 into n minus 1 to n, and where we can consider in the right side, that is w2n minus 1 n, and this up to wn into wn minus 1 into n minus 1, that is wn minus 1 square n. The formula of DFT as a linear transformation matrix we can write down, we can find out also capital N equals to Wn into small xn. Using matrix multiplication method we can find out capital Xn. As we have seen that Wn matrix in place of n, if we write down W4, then that is W04, in place of we write down 1, and then W14, W24, W34, W24, again we write down W44, W64, and case of last we write down W34, W64 and W94. We are getting from the previous equation, previous matrix also. And now we putting the value of W, that is the Twiddle factor, and we get this matrix. Now here we consider compute 4-point DFT of a sequence xn equals to 0, 1, 2, 3. So how to find out the value of 0, 1, 2, 3 DFT formation? So as we know, we write down the Twiddle factor part, that is the face part, and for the small xn part we considering 0, 1, 2, 3, and then we multiply it with the matrix multiplication method, and finally we get the value of capital X4 equals to 6. Next value is minus 2 plus 2j, next value minus 2, and lastly we get the next value, that is minus 2 minus 2j. Thank you.